Hey everyone, this is Matt with Learn Everything About Design, and in today's video we're in the garage, but we're not doing garage stuff. We're going to be doing a review of this 3D printed radio that I designed. And so in this video we'll talk about the inspiration for this, the reason that I built this, we'll go over the components I used, we'll talk about the design process a little bit, and then ultimately if you want to see a tutorial on how to design the housing or any of the other stuff that happened, then go ahead and leave a comment, let me know. The design is not actually that complicated, but it does have a lot of unique features. So for example, the bottom is completely flat with the exception of the feet. And then it does bulge out on the sides and the top. There's a lot of tapered sections for aesthetics, but it's also designed to be 3D printed with minimal support. And so the way that it's set up and designed is very intentional in terms of looking like a vintage radio, but also making it able to be 3D printed as easy as possible. And so if you want to see that, then let me know. But first, the inspiration. So a couple months back, probably February timeframe, I was sent a video on Zion Brock's radio and basically the speaker cover. So he was doing some 3D print thermoforming, and that was an inspiration for a video that we did on the channel. And I referenced his radio and his site on it. But ultimately, I thought it was a really cool technique. And I had just come back visiting a 98-year-old relative, and seeing the radio, it instantly made me want to build one for them. So what I could have done, the easiest path would have been just to donate to his project, download his design, print it, and build it, and be done with it. He did a lot of cool things in it, which I'll talk about when we get to the electronics, but it's not really my style. I don't like to just download files, print them, and make them. I like to make my own versions. So this is completely from scratch. I didn't use any of the components that he used. I didn't reference his code at all. I didn't reference his design at all. But I do want to give him credit because it was the inspiration to make this. And I'll talk a little bit about why I didn't use any of his components, but ultimately I wanted to just basically start from scratch and create something that was unique for my relative. So, his design, when I first started digging into the electronics, at the time, it was a lot of prototyping. You know, there was a breadboard, there were several components that did independent things, and you had to wire them all together. And I really wanted something a little bit more compact and a little cleaner. And so I started looking into making my own circuit board. And this is something I've done with projects in the past. We've covered it on the channel a few times. And as I began that process, I noticed on Zion Brock's website that there was already somebody in that community that was working on a circuit board. So rather than double up efforts to create essentially the same thing, I ended up just looking around to see what was available. Now, anytime I start an electronics project, generally I go to Adafruit first. There's no affiliate link, there's no sponsorship, but I generally appreciate the amount of effort they put into things like their Arduino libraries. I use their NeoPixel library a ton for all kinds of different projects. Also the components that they make, the custom boards and parts and things, and then all the tutorials that they have teaching you how to use them. So that's always my first stop anytime I'm doing a project. Then I have other resources that I go to like SparkFun, DigiKey, depending on what I need and what I can and cannot find at Adafruit. So I went to Adafruit for most of the parts for this radio. I looked up and I found there were two essential components that I could get from them. One was a shield for an Arduino that handled everything I needed. So it handled the SD card, handled the speaker output, the amplifier, basically all the stuff needed. And the other one was essentially the same thing as a wing for a feather board. And so I opted to go that direction for a couple of reasons. I've used the SAMD21 chipset in a bunch of different projects in the QT Py, Trinket, and other different form factors. So I was familiar with it. I also have Arduino Unos and other boards here, but I was really familiar with that. And it's also a very similar board that we're using for the GPZ GPS Speedo project, which I have been working on. It's using a Nexion display, and there's some other stuff going on there, but I haven't made great progress on that project, so that's a little bit of a back burner. So I opted to go that direction for a couple of reasons. One, the form factor was really small. Two, they had two different style feathers that went on top, basically the shields that plug in. one that had 2 outputs for speakers, one that had an AV jack for headphones. And so I could use those components in 2 different variations of the design. I could make like a battery powered MP3 player with a headphone jack on it, or I could do something like this with a radio. And so I wanted to be familiar with the code, the board, and then I could use it for other projects if I needed to. So I ended up going that direction. You can still buy those components. The actual feather is about $20 right now on the Adafruit website. And the shield, I think last I checked, was $25. So you're going to be into it about $50 to get the electronics. But if you were making a custom board, or if you were buying all of the separate pieces together, plus a breadboard and all the other components, then you're really going to be about the same price anyways. So I looked at it as just a simplifying factor and something I could do to support Adafruit, because again, I appreciate how much effort they put into creating their own products. Second, I wanted to use 2 speakers. And so I ended up buying a couple different variations. That is one difference. The Zion Brock radio, I believe, just has 1 speaker in it, and it's got a smaller rectangular speaker. I ended up going with 2 3-inch speakers. Now, these are both 3-watt speakers and 4 ohm. The actual FeatherWing that is in this will support 3 watts, and so it actually is pretty loud. It has really good sound quality, and we can do things in the code like, you know, put left and right for the volume and different controls and things like that. So I wanted to keep it kind of symmetric. I wanted to have that sound from both of those speakers, and I'm really happy with the way that it turned out. As I said, I did buy a bunch of different speakers. The speakers themselves are only like a couple dollars a piece. So when I was prototyping this, I bought a couple of different types of speakers just to try out, and I really liked the way that these sounded. That sort of, you know, the larger cones and you know, the structure of them, it just kind of worked better for this design. And that's actually really the thing that's driving the overall shape. One is the size of the 3D printer. This couldn't really get much bigger and still print in one piece. So the size of the speakers plus the 3D printer, in this case, it's a Bambu Labs P1S. So got about 240, 245 millimeters to play with. And that's kind of where the overall size and shape came from, was the speakers and that. Some of the other things that I ran into on Zion Brock's radio, he ended up using a single push button on the top, which I know why he did, because when you put a push button on the front, it actually rocks the entire radio without a bunch of mass in the bottom of it. So I moved the button pretty low. I dropped this thing as low as I could. I've got rubber feet on it. And it does work pretty well. This button has a pretty heavy spring on it, so I would probably change that to something else. In the future, it doesn't click, so it's just a momentary push button with not a lot of feedback. So that's a good reason why it would be in the top. Aesthetically, I didn't really want it there. I wanted it to be here, so that's why I put it where I did. And on his radio, he also has multi-function on the button. I didn't program that in. I just have this to skip to the next track. I did program in, or I do have the functionality to do a start-stop button, as well as a pause button, and I could incorporate those whenever I wanted to. I could put them on the back panel pretty easily, but I opted just to stick with one because, again, 98-year-old relative, I don't want them to have to learn to double tap a button or long press it to skip ahead to a next album or anything like that. So wanted to keep it as simple as possible, just an on-off knob for volume and one button on the front if they want to skip to the next track. So inside, again, relatively simple. The biggest problem I had, honestly, was with the potentiometer. The original one I ordered, which is on this one here, that original one, in the closed position or the off position, the 2 pins were disconnected. It was open, which is what you would typically expect if you're using it to pass power to a board. However, with the Feather board, there's an enable pin that you can ground that shuts power off from the USB to the rest of the board. So in order to make that work, in the closed position, I had to have a single throw double pole switch, because I tried to use things like NFETs and I never could get the circuit to work quite right how I wanted, and it would have a bunch of extra wires and soldered joints and things in the back of the radio. So I just opted to go with a completely different setup, one that had 2 pins that were closed in the off position. That way I could just take that enable pin straight to ground. and that shuts off power to the USB. So it doesn't have to be unplugged. I don't need an on-off switch or anything like that. It's all taken care of right here in the knob. So that was really important to me. That took probably, I'd say, a month, a couple weeks of just trying to get it to work with the components, and eventually I gave up, which is kind of a downside because I really like the shiny knob setup on this. It matched the bezel of the push button a little bit better. This one, the only one I could get right now was either black or this was more like a matte finish aluminum, but it still works out okay. You know, again, you kind of have to go with what components you can get sometimes. And in this case, I had limited availability. I had a couple brass knobs that I tried and other things, but I thought this one, you know, at the end of the day, that worked out okay. On the back side, it's pretty simple and straightforward. The board actually has the SD card on the back side or the opposite side of the power plug. So what I ended up doing was putting a strain relief in the housing and a strain relief on the back cover. So that way the cable is retained. You can't really pull it and mess up the board on the inside. And the SD card is accessible from the outside. You can push it and pop it out. It's not the easiest thing to get to because of the location of the board. I could do a better job with that if I shifted the board back a little bit further, but overall, I'm pretty happy with the way that it turned out. Once you load songs on here, you shouldn't have to access it anymore. If you do, I put 2 secret holes in the bottom of the back feet. And so you can take a small screwdriver through there and pop the back cover off. It was really important that there were no visible screw holes or hardware. So everything is pretty clean. There's nothing on the front side. The screws are on the back side from the inside. The speakers mount to this, the knob and the push button obviously mount to it. So I wanted to keep it as clean looking as possible. I looked through dozens of different images of radios from 40s and 50s. And one of the big takeaways I saw were really clean lines. So things weren't always like hard edges, but there was a lot of tapers and recesses and very clean lines. So I could have done more. I could have incorporated more features in here, but really clean lines, really nothing going on the outside. That was really important to me. So that's the direction I went with it. In terms of the 3D print, I ended up using a PLA CF just because I had it. I had black and gray here, and the only matte colored material I had here was orange, and I really didn't want a bright orange radio. And a lot of the ones I was looking at, like the tans and the browns for the wood material or the matte colored materials, were all on back order, and I couldn't find any that I wanted, or I couldn't find the material that I wanted from the suppliers I wanted in time. So I ended up just using this. But the contrast of the dark gray and the white, I think, look pretty good. This is just a PLA Tough, and again, PLA CF on the outside. The design itself, again, it wasn't really complex. The whole intent here was to make it smooth and clean. I didn't want a lot of extra lines. I didn't want any hard lines on the outside. I wanted it to look nice and smooth. And again, I didn't want any exposed hardware. So the first iteration of this, which is this one here, ended up having some pretty large rubber bumpers in the bottom, and I had it raised up off the table a bit more, and the button in the center, and that caused problems just because of how high you're pushing in the housing. I did go to the hardware store to try to get some steel flat stock that I could pack inside of here to add some mass, and the price was ridiculous. I mean, it was $100 for 6 feet of what I wanted to stick in here, and so I opted to redesign the housing a little bit, pushing the button lower, making the feet smaller. Ultimately, I could have probably stacked a bunch of washers in here, but it wasn't really clean like I wanted. Most of the stock that I have laying around here is either aluminum or tubing, so it didn't really offer much in the way of mass. So, you know, ultimately, you could have done a couple things. I could have paused the print and tried to carefully put sand inside the housing. I could have used some stuff that I had laying around, you know, different pieces of steel that I've used over the years for, you know, different like pry bars and things like that. But ultimately, this still works out okay. If you put your hand on the housing and you push the button, it's fine. If it's up against something on the back, it's fine. And if you push it, you know, if it's on a nice clean surface, the rubber feet keep it pretty well stuck to the counter. It works okay. Here on this sort of like rough workbench, it does tend to shift a little bit. I may, before I send this to my relative, I may try a different button here. Try something that maybe has a little bit less of a spring force to it to see if that works out better. It is a pretty strong push button. But again, it's optional. You don't have to press it to skip the songs. You can just turn it on and listen if you want to. So overall, that is, that's the process. The inside was really easy in terms of the electronics. I tried to make everything mounted to the front with the exception of the board because I needed to access the SD card from the back. I did end up using a code that was from a project on Adafruit from the Ruiz brothers. I will leave a link to their project as well. It's called the Gary Cole MP3 player, I believe. And I just modified a few things. I changed the range of the volume and flipped the volume around the min and max based on the way that this potentiometer worked. As I mentioned, I didn't use all the buttons. I didn't use the start, stop, and the play, pause button. I just used the next button. And I think I maybe modified one or two other things in the code. In the code from them, you could use it as is, depending on the potentiometer. In their project, they have an on-off slide switch. They have 3 buttons, and they have a knob for a potentiometer, so they don't have an on-off switch with the knob like we have here, but everything else is basically the same. So I thought that it was a really nice project, and again, they used the same feather board, and they used the version of the wing on top that had the audio output for headphones and not for the speakers. But again, it's the same exact code, so everything worked there. Next steps for me, I think I need to do a little bit more modification, maybe try to stick some mass in this thing, try out another push button. But ultimately it works. I'm happy with the way it works. I like the way that it looks. It's really clean. I've got a second one here that I could populate if I wanted to. But I'll probably try to make some minor changes. Again, just the push button is the big thing. And then take it to my relative and see how they can use it, if they like it or not. But I think it was a really fun project. I don't generally do these types of projects for other people very often. And usually when I have a project for myself, I kind of hack it together. So the file for this is not... It's not clean because, when you start to design stuff like this, sometimes you try something, it doesn't work out, you back up, you try again, and you make changes. And if the file is only meant for you, a lot of times I will do more of a direct modeling approach where I delete features or I remove bodies rather than going back and going to the original design. So an example of this is when I first made the shape on the outside, I just extruded the shape back. And then once I had that extrude, I created a midline curve on the top and then on the sides, and I lofted the surface from the front to the back to get the shape I wanted. Had I planned to do that from scratch, I probably would have just made an offset plane and done the profile front and back and curves and things like that. It would have taken a few more steps, but the timeline would have been a little bit cleaner. But again, when it's a project for just myself, I don't need to go back and make changes or modify this. I did change the size of it a little bit and modified the original sketch just to make sure it fit on the 3D printer okay. And everything rebuilds just fine. But again, those kind of little things, those are changes that I would make for a tutorial. Or for example, I would do it properly rather than the way that I kind of hacked some of the features together. But at the end of the day, I think that it's a really nice project to do for somebody. Very simple offline MP3 player. I really like physical media. So if this thing had a tape deck or a CD player on it, that would be really nice. But this is kind of the next best thing, especially for somebody that's getting close to 100 and you just want to give them something where they can turn it on and listen to music. I think that'll be a pretty nice gift to give. I do suggest if you want to build something like this, check out Zion Brock's radio. I think it's a really cool design, and there are a lot of people that are licensing that and building them and selling them at trade shows and things like that. So I would definitely check out what's available there. If you want to design your own, I'll leave all the links to the different components that I used on the inside, so that way you can pick those up. So it's a couple components from Adafruit, a couple from DigiKey, and then for probably about, I want to say $60 to $70, depending on where you are and how the prices fluctuate. You can have all the electronics and all the pieces inside to make something like this work for you. So if you have any questions on the design itself, if you want to see a tutorial on how to build this or how to design the housing, then please leave a comment and let me know. If you like this kind of content, consider subscribing. I don't generally say like, subscribe in these videos, but I think every little bit does help. We've gotten to this point where we're at almost 80,000 subs without really pushing it, but the space is getting kind of crowded, so you might hear me say it every once in a while from now on. So I'll go ahead and I'll leave, again, links to everything in the description. As always, thanks for watching, and we'll see you in the next one.